Hello, my name is David Thredini, and my partner Dale and I have created a project on deauthentication attacks. So what are deauthentication attacks? Deauthentication attacks are a type of denial of service attack. In this attack, an attacker uses a wireless access point's MAC address to disconnect a user from the same wireless access point. So pretty much the attacker sends a deauthentication packet or multiple packets across the network, and this causes devices that are connected to the network to disconnect from it. A common tool to conduct deauthentication attacks is the aircrack-ng suite, and here are some commands below that are used to set up and then send a deauthentication attack. So the sudo apt/get install aircrack.ng, that's just for using the Linux command line to install aircrack or on Ubuntu. Next is the sudo airmon-ng. This will show the wireless adapters currently on your device. And then there's sudo airmon-ng start, and then the wireless adapter name that you got from the previous command. This will then start a monitoring on the wireless adapter that was shown from the previous command, and also give a new interface name, which we use later. Next command is sudo airdump-ng. This then the interface from the previous command that was newly created, and this will then bring back the hidden MAC address of the wireless access point of the wireless network. And the final command is sudo airplay-ng -O-0-A followed by the MAC address of the wireless access point -C followed by the interface from the previous two command. So a little information below about the file command is the -O is for making sure a deauthentication packet is being sent out. The 0 is to make sure that the deauthentication packets are being continuously sent out. The -A, that is for setting the MAC address of the wireless access point, and then the -C is the interface created with the airmon command earlier. So what are the purpose of deauthentication attacks? Well, deauthentication attacks was not created to be used as a malicious hacking tool. It is a protocol that allows a device to disconnect from an access point normally, and has its positive and as well as its negative uses. One of the main positive uses of it is that it disconnects unwanted or malicious devices from the network. A popular example of this is by a coder named Julian Oliver. He created a script to disconnect specific devices from network. This includes Google Glasses and also cameras, like hidden spy cameras from a network. Some of the malicious usage is that it's used to capture WPA/WPA2 handshakes by forcing clients to re-authenticate. Users would have to reconnect to the wireless access point, and this allows an attacker to capture WPA/WPA2 handshakes. This information could then be used in a brute force attack on the wireless access point. Another malicious use is that it can be used for traffic monitoring attempts. So after being deauthenticated, a device will try to authenticate again to connect to the wireless access point it was just disconnected from. In this case, an attacker can then set up a fake access point that mimics the targeted access point previously stated. So then the device will then try to connect to the fake access point because it is closer and has a stronger signal. The attacker can then monitor the in and outgoing traffic of the device. So, me and my partner Dale have set up an experiment using Kali Linux and the aircrack-ng software package, and we will show you how to conduct a deauthentication experiment. This should only be done on a network you control or own.
Hello everybody, my name is Dale. I am following up with what David has said about deauthentication attacks. He gave us a very nice overview of what a deauthentication attack is. Now, my objective is to actually put this into a context that is understandable, even if you've never done this kind of attack before or seen it in action. So the first thing you need is a good computer. The second thing that you're going to need is not just a computer, but one that is operating with a specific operating system known as Kali Linux. I'm sure there are other ways to do deauthentication attacks with other operating systems, but for our purposes right now, we're going to emulate what a hacker might be doing according to the context of the case study that we've seen before. Okay, so just to put this into context a little bit, what we're going to do is try to emulate what would happen if you were pinned down by the police at some location and you were trying to brute force your way into a network. That way you could send a message through the internet to somebody else. Of course, the first thing you should do is take a look at the software that you are running. We're using VirtualBox today to set up our lab environment here, running a Kali machine called New Kali. I will bring that up right here for you. So Kali Linux machines are very easy to install as a virtual machine, very easy to install really as an operating system, but pretty simple to use too. Now, I'm not going to go into the details of Kali Linux, but I will say that every time I log onto a Kali Linux machine, I always like to make sure that it's functioning properly first, and I always make sure that my command line interface is comfortable and ready for use. So I usually run just a handful of commands just to make sure that it's working properly. Here we see that it's connecting to the internet, which is perfect. Oops, still are. We can see that I'm currently logged in as root, and we can see what directory we're currently in. So it looks like Kali Linux is working just fine here. Now I'm using a special software or a special application known as Terminator right here. That will be important a little bit later when it comes to capturing the handshake, but let's not get ahead of ourselves yet. Terminator is just a little more comfortable to use than the traditional terminal, which looks like this. So it looks like we have a number of things going on here, but I think Terminator is just easier to use. Great, so now we know that Kali Linux is working successfully. Well, now what? We want to look at the network interfaces, and the way we do that is by using a command called ifconfig. This will tell us what network interfaces are open, what adapters are running, etc. Now, you'll notice I only have two up right now. I have this one and I have this one, right? ETH0 and the loopback, right? This has not been plugged in yet. This is our network adapter. When I plug this in a minute, it's going to show up as a brand new network interface, and that's going to be the key to executing a successful deauthentication attack. So what I'm going to do is simply take this, plug it right in. I'll hit this devices key, devices, USB, and make sure it's good to go. Cool. Let's try this one more time. Ifconfig. And boom, now we have a third interface here, right? We have LAN 0, WLAN 0, and then we have this address associated with that. Great. So in the example that we've probably seen before, the MAC address was actually changed from this to something different. Now, this is actually very easy to do. It just requires a couple commands just to change the address of our MAC to a couple things here. First I'm going to do is take take it down. So ifconfig, if I can type, ifconfig, we'll say LAN 0 down. There it comes back without a problem. That means that LAN 0 is down. We run ifconfig again. You'll actually see that it doesn't pop up there. Cool. So ifconfig LAN 0 up. We'll bring it back up. Ifconfig. Ifconfig. Bang. Now, so let's bring it back down. Ifconfig LAN 0 down. There, now it's down. Now we can actually start adjusting it and changing it to our preferences. So what we want to do is change the name of that adapter. So ifconfig, we'll say LAN 0. We're going to change the hardware address to, I think the one in the example was this. 1337. Now this could be anything in the entire world, but this is just a name that was used in different lectures. So we want to make sure that we are in alignment with that. So we'll go ahead and keep it there. It'll come back without a problem. I'll bring it right back up. LAN 0 up. Good. Ifconfig. And now we can see we've actually brought it back up, and it has a brand new MAC address of deadbeef 1337. Great, so now we've changed the MAC address of our hardware adapter. Now we've successfully disguised our tracks, right? Because now we don't have a MAC address that's associated with our specific device. The next thing we want to do is go into what's called IWconfig, and we want to change the configuration of this adapter so that it is actually able to sniff the entire network. Now, if you were pinned down by the police and you were trying to find any kind of network anywhere around, this is probably a step that you would take. So the first thing we're going to do is type this command. Which is IWconfig, and we'll see that we have it in monitor mode. Monitor mode means that it can sniff packets from anywhere nearby. It's monitoring the entire network. Now, monitor mode is not enabled by default. Usually it is in managed mode. The way you bring it into monitor mode is by simply typing ifconfig WLAN 0 mode monitor. Right now, if I run it, it's going to say it's already in monitor mode, or it's not going to have anything at all, right? So we'll say IWconfig one more time, and we'll see again it is still in monitor mode. This is something pretty important. You can look at my screen right now. You will see that it's sniffing on the 2.4 gigahertz frequency, right? It is only sniffing on 2.4 gigahertz. It is not sniffing on the 5 gigahertz, which is what this device would probably do. This device costs about twice as much as that one, and that one is 10 times more reliable. So right away, I would assume that if you have a 5 gigahertz network, you're automatically a little bit more secure just because the hardware necessary to actually sniff on a 5 gigahertz network is more expensive. Now we can clearly see that the frequency is where we want it to be. The mode is how we want it to be. We are ready to finally start finding our victim network, the one that we are going to attack with so many deauthentication packets they don't know what to do. The way we're going to do that is with a command called arrowdump ng. Arrowdump ng, and I'm going to, not arrowdump, arrowdump. Arrowdump ng, very good, and we'll give it the interface we want to use, WLAN 0. And right away we can see that it's going to start scanning and looking for different networks in the area. I'm going to push Control C, and that's going to stop it right where it's at, and we can see all these different ESS IDs and things, and we can see all kinds of information already. The most important pieces of information that we need are these right here. This is the BSS ID, which is the network ID. The power indicates how close it is to us. So if we were on the run from the police and we needed to get to a strong network, this is what's going to tell us exactly how strong that network is. Data tells us what's coming out of the network. It looks like none of these networks are very busy right now because they're all zeros next to data, but in some cases that number will be quite high. The channel indicates the radio frequency that it's coming over. You can see the encryption information, which in this case they are all WPA2 encryptions with a cipher of CCMPs. So these are all really secure networks. Now, in the example that we're going to push forward from now, we're going to assume that we're using a WEP network, which is significantly easier to crack. But for our purposes here, we're just going to push forward and do the WEP decryption, even though we're on WPA2 networks, which hopefully you'll see will fail. Now, I don't own any of these networks that you see right here. I do own this one. So this is going to be the network that we target. Not to worry, I've changed all the important information prior to submitting this video. So I promise this looks nothing like the way the network is now. But anyway, this is the network that we are going to attack, but we need to learn a little bit more about it first. We need to figure out what exactly this network is doing. And the first thing I'm going to do is make sure I have some device attached to this network, and in this case I'm going to attach my cell phone. So I am just going to the settings right now on my phone, and it is now connected to that network, Dale Wi-Fi. Now, my network at home is divided between a 2.4 and a 5 gigahertz, and usually I spend more time on my 5 gigahertz network because I know 5 gigahertz is just naturally more secure because it's a different type of network. Not because like the network itself is different, just because of how it's configured. So now I am connected to Dale Wi-Fi on here, which is great, which means when we target this network, we should see this device attached to the network, and let's see what happens. So the first thing we want to do when we're targeting our packets here is to do arrowdump ng, and then we want to type --BSSID, and we want to give it the MAC address that we are, aerodump, ng dash bssid. Great, and then we want to make sure we copy that. Bang, good to go. So our BSSID is ready to go there. Now the next thing we want to do is tell it what channel. In this case, it's channel 11 channel, and we'll say 11, no problem. Let's go ahead and give it a write file too. Let's write it to say, I don't know, demo of Wi-Fi. Why not? We'll just call it that. And then we'll give it our interface, which will be WLAN 0. And if I expand this out a little bit, you'll see how that actually looks. WLAN 0, bang. I run it, and right away it is scanning that network, looking for devices. So in just a second, we'll see it pop up with the MAC address of my actual cell phone here. So we'll let it scan for just a second, and I'll be right back with you. Oh, there it is right there. Happened faster than I thought it did. Oop. So right away, we see that we have a network called Dale Wi-Fi with all this information that we saw earlier, but now we also see that we have not only the BSS ID of it, but now we have a station, which is a MAC address, right? The station is my cell phone. That is the exact MAC address that corresponds to my cell phone. And again, I've made sure that it's changed by now, so don't bother doing anything with this information. It'll be useless to you by the time you do. So now we've figured out our victim computer, we've figured out our victim network. Now all that's left to do is to actually de-authenticate this machine. So the way we're going to do that is by using a very simple command. We're going to use the AirPlay suite, AirPlay -ng. We'll say deauth, indicating what kind of attack we'd like it to do. You can actually put a 0 or an O there if you want to, but deauth is just a way to keep it simple for, you know, just to know exactly what it is, because that can only mean one thing. So deauth, and we're going to get it. And then we're going to give it some large number. So I'll give it, say, this many packets. I think it's like 1 million packets. Is that 1 million? I think it's 1 million. So 1 million packets. Then we'll type in -A, and I'm going to give it the BSS ID of the network, which is right here. I don't even have to type it out. I can simply copy it, and I can simply paste it right there. The next thing I want to do is give it the MAC address of our victim, which is right here. I can copy that. Oops, and I can paste it right there. Now we give it the interface we'd like it to sniff on, which in this case will be WLAN 0. And like magic, I'll try to get this in frame on the camera here. You will see my phone go from connected to the internet to not. Did you see it shift from the wireless network to LTE? Probably not, because cameras are silly, but I promise it did. And you can see it happening on the screen right here. It's sending 1,000,001, you know, of these de-authentication packets directly to this phone, rendering this thing permanently unable to access that network until the attack stops. Of course, if I do stop the attack, it will go right back to activating on the Wi-Fi network. So we've captured a lot of information. We've successfully de-authenticated this machine, the cell phone, from the network. But what do we do with that information that we wrote in the log file? I didn't do that just for fun. Well, that information is actually what we're going to use to try and capture the handshake or try and capture the passkey to decrypt it and figure out how we're going to gain access to this network. So the way we do that is with a pretty simple command. First thing I'm going to do is show you that we have different log files that we wrote to. Remember, we wrote the --write, and we wrote to demo of Wi-Fi.cap a couple minutes ago. Perfect, that's right there. We're going to use that file, and we are going to figure out this passkey, or at the very least, we're going to try to. And we're going to use a tool called aircrack-ng. So we'll say aircrack-ng, and then we're going to call it demo of Wi-Fi, right? And we'll say .cap. And without further ado, we'll let it do its own thing. And of course, it's not going to give us anything because nothing has been sent, right? It only read 56 packets, so there really wasn't a whole lot for it to work with there, so this attack actually failed. But if this were on a WEP network, this attack would have actually been really successful and would have been able to capture the handshake, decrypt it, and then we would have had the pass key.